Once again, this is a Lunch and Learn webinar based on SolidWorks Motion tools. My name is Jim Byrne. I'm an applications engineer for DASI Solutions. One of the things that I'd like to do before I get started is go over an agenda so we're clear as far as what the objectives are for this presentation. The presentation is for anyone who would like to know more about motion inside of SolidWorks. I'm going to be moving rather quickly so I can cover some of the basics as well as some of the advanced tips and tricks for using these tools. I'm going to start with motion inside of SolidWorks before using those techniques inside the Motion Manager. And then once we get through the Motion Manager, we can start talking about other things like advanced motion techniques. I also threw in there using camera views. It's not necessarily part of the, I guess you could say, objective when it comes to the webinar, but it will just take a minute to show, and you might be interested in it. And then we can talk about some of the other tools that are available, like motion simulation and event-based simulation. I'll mention this again when we get to that portion of the presentation, but you should know that the motion simulation, when we get to it, is part of SolidWorks Premium. Most of what I'm going to be showing today is available to anyone who has a seat of SolidWorks, even if it's just SolidWorks Standard. Event-based motion, I'd like to touch on that as well. This is part of Simulation Professional, and it is new in 2010. I threw this little picture in there because what we're doing is making our assemblies alive, and this is what I want to focus on. Well, like I said, the first portion that I want to mention is SolidWorks Motion, and this is going to involve simply moving components inside your assembly documents, and also using the reference triad, which some of you may not know is available. And then that will lead into things like looking for a collision, using physical dynamics while moving those components. And another function that is kind of hidden out there, it's the record function, in case you want to record any of the motion that you're doing. This actually works inside of part documents too, if you simply want to switch between configurations and show an animation of that. I've used it in cases where you want to show how maybe a sheet metal component is folded or flattened. You can walk through those configurations using the record function and save it off as an AVI. So let's take a look at SolidWorks. I do have probably about 16 assemblies that I'm going to be walking through. So once again, I'm going to be going over these very quickly. In fact, all the information that I'm going to be showing is, it's about 5 days or a week's worth of training material. So we're going to condense this into a very small time slot. In fact, I should also mention that if you do have any questions, I'd like you to send an email to my email address that will be shown on the last slide of this presentation. And I can, what I'll do is answer those emails, and I'll also make sure that they're posted as frequently asked questions on our DASI Solutions webpage. Along with the webinar, we're going to record this in case you need to go back and see anything that I'm going to cover, or maybe you'd like to pass this on to someone else in your organization if they happen to miss it. Okay, well, let's jump into SolidWorks. I do have this assembly open, and I'd like to start by just talking about motion in general. I'll go over this real quick. There's a couple of tools in here that you may not be using currently. For example, let's jump into the Move Component tool. Now, the Move options have been in the software as long as I can remember. They may have been updated a little bit since I started, which was in '98. But you'd have the ability to simply free drag your component. That's there by default when you just pick and drag a part. But you do have other options like moving along XYZ that allows you to move in just the Y direction or just the X or the Z direction, depending on which way you move your cursor. And we can also move along an entity where you select an edge, and you can move along that edge just by dragging and dropping the part. delta XYZ, this allows you to punch in a number, maybe in the X direction, so you can move in the X. Or negative values too. Put in a -10. You can put in negatives to move in negative directions. And also XYZ position in case you'd like to use XYZ coordinate values to position your component. Now, a lot of those options are available by using the reference triad. This one has not always been in there. It's been in there for a few years. Right-click on a part, move with triad. This gives you basically all the same functionality where you can move a component along X, Y, and Z by dragging and dropping these arrows. This comes in handy, especially if you're creating animations at times without mates on those components. And you can also move along Y and Z at the same time. There's options there too. And now if you want to move in a different direction, just as a tip, you can hold down your Alt key and drag and drop that dot on the reference triad to another edge. And then we can not only move along that edge, but then you can use these rings here to rotate the component along that edge as well. So use the reference triad if you haven't already. Give it a chance. And now let's move into some collision detection and physical dynamics. Okay, I have a few examples that I want to bring up for this. This is one of them. When using the move component command, it starts out with the standard drag option. As I move the part, you'll see it will pass through all these components. Okay, it doesn't detect the collision as you move it. But we can turn on collision detection. And now as I move the component, when it does run into another piece, it's going to stop at collision. You can see that there with the checkbox. And there's some advanced options like highlighting the faces that hit, playing any sound that you want. A lot of users like the Homer Simpson sound. I don't think you'll hear it on mine because I have my headphones on. But let me show you this real quick. See, as I move the part, it will hit the casing there, and you can see it does stop, and it highlights those faces when they touch. Now, when it does hit, the part does not move anymore, okay, until we move it back away from that component. So once it does touch, it does happen to stop completely. So there's whereas it's a little bit different when you turn on physical dynamics. When I turn this on, there's a couple of options that I want to mention in here. One of them is being able to detect using physical dynamics on selected components. This is one way to make this a little bit faster on your computer. We can select the components that we want to detect it between and select resume drag. Now stop at collision is turned off this time. You'll see that when the component hits, it not only stops, but it will slide up and down along that part. Okay, so you can do a true fit form function on your assembly document. When that part hits another one that moves or that has degrees of freedom, you'll see that one will move too. Okay, and then we can also move that cover to place that ink cartridge in there. Another thing that I'd like to know when you walk through this process is some of the options that are available. We'll start with the sensitivity. The sensitivity, a lot of times I like to just move this all the way over to minimum because I get a little bit better, I guess you could say, performance when dragging it to minimum. If you have very small features, complex geometry, then you may want to drag and drop this over to max. It'll take a little bit longer to solve. It's something to keep in mind. Basically what this does is it's the frequency in which SolidWorks detects the collision between components. If I drag it all the way to max, then it will detect it every 0.2 millimeters, I believe. Over to minimum, it does it every 20 millimeters, which is just fine in this study here. Okay. I may also mention inside of this this property manager, as long as we're here, I'll turn this back over to standard drag and check the box for dynamic clearance. Dynamic clearance, this one, it's very basic. It allows you to select a couple of components. Let's say, for example, these two. And as I resume drag, it will give you a dynamic dimension between those components. And you can see the dimension changing on the screen. Now, unfortunately, this doesn't do it for faces. It only works between the components themselves, any faces of the component. Besides the dimension that you'll see on the screen, there's also an option to minimize that distance, so we can make sure that these parts never come within 10 millimeters of each other. Again, as I resume drag now, when it does come within 10 millimeters, it will stop when we hit that value. Okay, so that's another option that we have in there. And if this is a kinematic type motion, then you'll also see if you're not using this minimum requirement, it will show you what the minimum distance is between those components as it runs through a full range of motion. This is just a real quick one. It's I've got an indexing situation here, a Geneva wheel. Again, when I use move component collision detection, when we use this, it will stop when those components touch. If you turn on physical dynamics, you'll notice that we can run through a full range of motion. And the benefit here is you don't need mates to do this. Obviously, the two components their position is mated, but this is where physical dynamics can really come in handy when creating AVIs. Okay, again, I tend to use a minimum sensitivity unless something happens in your assembly where maybe it skips over a component when running physical dynamics. Let's see what else we have in here. I've got some pretty good ones. I might actually jump over to this clock. It's not a real practical example unless you actually make clocks, I suppose. But again, with move component, we can turn on physical dynamics. These parts all will come into contact with each other. You'll notice we have an eccentric shaft back there, an inner and outer cog. As I move the minute hand, you'll notice that when those parts come in contact with each other, it will move the gears in the background, so I get an accurate representation of the minute hand and the hour hand. Okay, this is a pretty cool one. I like to show it. If you've been through our Essentials class over the past 4 or 5 years, then you've probably seen this model before. It was part of the Essentials training guide. Now, the next one that I want to show, let's take a look at my PowerPoint here. Oh, the record function. Let me show you this one too. It is a nice piece of functionality. I did skip across it. Almost forgot to show it. It's real quick. If you are moving components, rather than using the motion manager down here at the bottom, which we will get involved with, as you move these components, you can record all that motion. See up here, I've got the record button. I added it to my standard toolbar at the top, and it will ask you a few questions, like, for example, what do you want the aspect ratio to look like? We'll go with 1:1. We can put in the resolution of the video, and maybe frames per second. I'll just leave this as 7.5. When I click on Save, actually I'll put this over on my desktop so we can see it too, and we'll get a chance to see how that AVI looks. Now, as I move this component, let's turn on physical dynamics. It's recording all the motion that's happening, so it's a little jerky, and you might not notice it on your screen, but on mine I do notice it. It's a little jerky at first because it's recording several frames per second, and see, as I move this around, it's going to record that. Or even if I just rotate my model, I have my 3D connection device here. As I rotate it around, it's recording all of this, and then we can stop that animation or the record, and I'll minimize it to my desktop so you can see this. And I'm not sure how this AVI is going to show on your screen, but again, it's just recording everything that you did, and we didn't have to set up any keyframes or any paths inside the motion manager. It's just a matter of recording it. So, pretty neat little tool. It's been in the software for quite a few years, but I myself don't use it a whole lot. It's a bit hidden. The next thing that I want to show as far as physical dynamics is concerned is when you're moving components inside of SolidWorks, you can only move one component at a time. So what I'm doing here is using the Motion Manager to simulate a dynamic study. I'm going to pull up an assembly, this one here, and you'll notice I'm going to take into account the gravity. There is no friction when using physical dynamics. That's something that we can bring up later with motion simulation. And also it assumes that all the components are rigid. There are no material properties like the stiffness of the components or anything of that nature. It's a very simple simulation. So I'll pull up this assembly. Let's close out of this one. Okay. I'll pull up my motion study so you can see this too. Now, one of the things you'll find is this assembly has 0 mates. Everything in here has all 6 degrees of freedom except for, I guess, this slide right here and the floor are fixed, but everything else has all 6 degrees of freedom. I'll just go ahead and play this. It's already been run, so it doesn't have to calculate anything. That's run at half speed. But you can see there's 400 blocks in there. In case you're wondering how I created the blocks, I just put one in there and I did a linear pattern of that, and then basically I right-clicked on that linear pattern feature to dissolve it, and it just placed all the parts in the tree. You can see again there's 400 blocks in there. Well, it's detecting the collisions, the physical dynamics between all of those components during this while it's processing that animation. So there's quite a bit going on. I believe the length of time it took to solve this was somewhere between 5 and 10 minutes, which is very fast. The solver has actually been rewritten in 2008. So a lot has been done to improve the performance of solving these AVIs. You know what? This is a very cool animation. I'll show it again. In fact, I'll play it at 1/4 speed so you can see it again. Okay. If you're like me, you're a kid at heart and you just love these kind of animations. I must have watched this one probably about 20 times or so at least, right after I did it. And I think what I'd like to do is take a look at my poll questions as well. There's a couple of poll questions I'd like to ask you as long as we're in this presentation. Oh, one of the questions that I probably should have pulled up earlier is what exactly you are interested in as far as this presentation is concerned, whether you're mostly interested in motion in SolidWorks or motion simulation, event-based motion. I'm going to launch this poll first just to give us a general idea of that. All right. Well, thanks for taking a look at the poll. In fact, what I could do is share the results with you so you can see those, just to give everyone an idea of what it looks like. We're pretty even across the board as far as what you're interested in seeing in the presentation, which is good for me. You know, I'll make sure that I cover these as evenly as possible. I'd also like to know if you've had experience using the Motion Manager. Real quick, if you don't mind answering this one for me. In fact, I'll share this one with you too. So there's a noticeable amount of you who have never used the Motion Manager, and then of course a few of you have used it in the past. So yeah, I'll just make sure that I can answer as many questions as I can as we go through here. Again, we just have 1 hour, so I'm going to try to cover quite a bit in a short period of time. Before we talk about things like using motion simulation, we need to talk about using the Motion Manager in general, and especially for those of you who are interested in taking the motion that we have inside of SolidWorks and applying it in the Motion Manager. When you're moving components in SolidWorks, you have the ability to move one part at a time. When you're using the Motion Manager, of course, we can create multiple paths for your components and to show a function of your design and maybe even generate an AVI if that's what you're interested in. Okay, so we'll take a look at a few of these topics. I'm going to run through this very quickly. So you may want to go back to this presentation if I did go through it too fast, especially if you're interested in knowing how to set up these paths. I have a motion study that has I have a motion study tab down here at the bottom. You do have the ability to create as many of these as you want. I should mention that if you do create one and you would like to keep it that way, you don't want to mess it up, make sure you create another motion study or a duplicate of that one in case you'd like to make changes without affecting the original one. Well, the first thing that I do when I'm using the Motion Manager is disable playback of view keys, because I'm not interested in the orientation just yet. Sometimes I finagle with that a little bit toward the end of the animation. So we'll disable that first. And I'm going to hide my toolbar up there at the top. Okay. Well, I'll walk through just a few paths, a few options that you have available when using the Motion Manager. The first thing I do is drag and drop the time bar over to a certain time and move a component. This is one way of moving your parts. Later on, I'll talk about using motors too. And each time you drag the time bar and move a part, you'll get a keyframe, and you can see that these will show up as you're generating them. And I'll talk about the different colors in one of my slides too. You'll see a key or a legend for all the colors that show up inside this interface. Now, I may also create a path for the arrow up here as well. Now, for the arrow, you don't necessarily have to do this, but I can move these keyframes around too, or these keys, drag and drop one over here so the path starts at 3 seconds. Move the arrow out, and again, it generates a path for it. You can play these at any time. Just go ahead and hit the play button or the calculate button to see what it looks like. Now, you've got a few other options in here. For example, the pull ring. We can change the interpolation mode of this to have it ease out, so that at the end of the path it will be 0 acceleration. Again, if I calculate this, I'll zoom in so you can see it. As it moves out, it will slow down when it gets to the end of the path. Oh, I think I right-clicked on the wrong one. There we go. Okay, I'll calculate it again. Again, you'll see it slow down near the end of the path for that component. You can also change the appearance of these parts. For example, at the end of the animation, I may want to hide this component, hide that arrow. And you'll see that it gives a different path for the appearance, which can be modified when it comes to the time frame for that. Then if we calculate or play this, you'll see the arrow will gradually turn to transparent or hidden color, okay, during that period of time. We can do the same thing for colors too. There's my main body, for example. I may decide that at some point during the animation that main body is going to change color. Just make sure that part is selected, change the color, and make sure that you change the color in the assembly document. Don't change the original color of the part because it won't create a path for it. We'll change it to red. Maybe it's getting hot or something like that as we run the animation. And again, I can play that, and you'll see it will gradually go from this point, it starts to change to red. So it's not an immediate change, unless, of course, those keyframes are very close to each other. One of the other things that I'd like to mention is components that are fixed or they're mated. Exploded views are one way to move these components. Obviously, you can delete mates and then you can move a part via XYZ coordinates. But if this part is mated, I can leave the mate in, and let's see, I'll turn on my toolbars here. Create an exploded view. Okay, now when I add these steps, drag this up. Okay, I'll add several steps for this piece, and I'm just going to eyeball it. So forgive me for not getting too exact here. drag and drop this in and accept that explode view. So of course we can right click on it to collapse it to put it back. Now when I play this, you'll see that it's, oh I'm sorry, excuse me, we need to generate the paths for this. Under the animation wizard, which is this camera with the magic wand on it, we can now use the explode option in here, and it will automatically generate the steps or the paths for those explode steps. Our start time is 5 seconds, which is where our timeline is right now, and this will run for 4 seconds. Okay, now if I scroll down, we'll see it generated those keyframes and paths. Now go ahead and play it so you can see it. And the benefit of having those keyframes is we can use our zoom option here to zoom into the timeline, and we can drag and drop those around. So they're not static. We can place them wherever we want if we want one of those explode steps to take a little bit longer, for example. Okay. There's one other thing that I want to show in here. It's the a rubber band. Now, some of you may have seen this before. I'm going to show another component. I have to make sure that before I show it, I drag my bar for the timeline all the way to the beginning. Otherwise, it's going to create an appearance path for this component. So we'll hide this piece. And this component works a little bit differently than the others because it's going to be driven by this pull ring. In fact, how about this? I'll go ahead and edit the sketch for the sweep. Notice if I zoom in, this line segment on the path for that sweep has an external relationship, a collinear relationship to the axis of the pull ring. So I'll go ahead and rebuild this. And what you'll notice is when I play my animation, oops, zoom over here a little bit. As I play this, every time frame, every keyframe, it's going to rebuild that sweep on that rubber band. I'll go ahead and play this again so you can see that. Okay. Again, every frame is going to rebuild the parts, including the external relationships that you have inside the assembly document. Okay. So kind of a unique way of creating motion inside of your assemblies. Well, real quickly, once we're done creating all the keyframes and the paths for our components, I'm not going to actually create an animation here, but I will walk through it. When you click on the Save button inside the Motion Manager, you'll find that there's options for the aspect ratio. Personally, I like to go with 1:1 and maybe drop the resolution down a little bit and put in the frames per second. For me, I typically put in 15 frames per second as just a default. And when we save it, we're also we have an option for the compressor that we'd like to use. The default is Microsoft Video. Anyone with Windows can view these files, but you can also choose from other codecs that you have installed on your system. And 85 is a pretty good compression quality. It'll keep the file size small. If you crank it up to 100, the file size will get very big at times, so be aware of that. You don't want to go too small, though, because then you'll start to lose the quality of your animation. So I like to stick with somewhere around 85. All right. Now I'll go ahead and cancel out of this. I'm going to go to another model. I added this slide. You could take a screenshot of it if you'd like, or you could also come back to this webinar since it is being recorded. In fact, I'll probably put this PowerPoint over on our webpage as well once we get the webinar up. I actually haven't found this under the web, or maybe I didn't look hard enough for this legend, so I created a quick one. These are all the colors of the paths that you'll see inside of the Motion Manager. Whenever you see a motor, a driven or a driving path, or a driven path, explode steps, maybe an appearance path, these are the colors that you'll see. So you could use this as just a reference. There's other advanced techniques that I'd like to mention real quick when making animations, since we are talking about the Motion Manager. These are just real quick tips. I don't want to focus on them too much, but you might like them. I'd like to start with this gripper arm over here, creating a dynamic section of this component. In fact, I think I'll start by showing an AVI of it. This is the gripper. Hopefully you can see this. It opens and closes. And you'll notice that I created a dynamic section that will show the inner components of that assembly as it opens and closes. So you might be interested to know how this is done. I'll just give you a real brief look as far as how I did this. If you have questions on it, then that's something that I can answer if you were to send me an email as well if you have any trouble with it. Let's go ahead and close out of this animation, and I'll pull it up in SolidWorks. Okay. Now, one of the parts that you didn't notice before was this big block. And it doesn't matter how big it is or what it looks like. Basically, what's happening is I have a block that's moving closer to this assembly document. And I have an assembly feature that is, it's a cut extrude, and it's attached to that block. You'll see if I edit that feature, it's basically a cut that's cutting nothing until that block starts to move. And it's going to move 20 millimeters, which will force this assembly cut to cut away some of the components. And I say some of the components because I used the feature scope to exclude a few of these parts, like the jaw, from being affected by that cut. Oh, including the shaft on the inside. So in fact, what I could do is if I pull up the Motion Manager, you'll see if I move this over just a little bit, you notice that that cut is starting to take place. Okay, as that component moves closer into the assembly, or that block moves into the assembly. And again, I have that block actually hidden during the animation while I'm recording. You want to make sure that when you do hide it, that the timeline, the bar, is all the way over to the left, and then you can go ahead and hide or show that component. Okay, and then it won't create an appearance keyframe or path for that part. Okay, and I don't think there was anything else in that part that I wanted to show, just the fact that you could use an assembly cut to show a dynamic section through your assembly. The other part that I wanted to show was this one. Again, a very quick one. And this has to do with top-down relationships, again, external relationships. You notice that the water that I have inside of this tank, I'd like to create an animation that shows the water, I guess, coming out of it. Not necessarily out of a spout, but see the water coming down. I have a cavity feature in here that I can edit so you can see it. See, it's just a big square block, and the cavity feature is going to subtract everything outside of the tank. So, once again, like the rubber band that's over in the Nerf gun, if I move that component down and rebuild, it's going to update that cavity feature. Okay, so basically what we're doing in this animation is we're creating a path. In fact, I can do this right now. Let's say this takes 4 seconds. I'll drag that water down and see it created a path for the water. Now every frame during this animation is going to update the cavity feature. Okay. So you can see that components don't necessarily need to remain static. You can make it look like a part is bending. You can make it look like, in this case, the water is receding. You can use your imagination there. External relationships can really come in handy. Camera views, I think we have just a minute where I can at least show you how a camera view works inside of an assembly document. This does have to do a little bit with motion because I'm applying motion to a part that has a camera that's attached to it. So this may seem interesting to you. Let me see if I can find an animation for it. I think I already saved one. And I don't know if this is going to, how well this will show on your screen, but again, I've got a block that's moving through this plant, and there's a camera that's attached to it. Now, I don't know how many of you have actually added a camera to your assembly, but the unique thing about cameras is you can't see what's behind it, because I think most of you know that when you zoom in, you can never zoom into something. You can never zoom inside of a housing. The only way to see inside of a housing without hiding it is to use a camera. So that's how this one is accomplished. You know, once again, I think all I really do need to mention is that I don't necessarily want to open up this assembly because it's a rather large one. Let me at least pull up an assembly document of some sort so you can see where the camera is. But again, when you go to lights, cameras, and scenes, we can right-click here and you can add a camera. Basically, you'll have a part, a block, or something of that nature where you'll select the position of the camera, select that component, and maybe an edge on that block as a direction for the camera. So again, as that block moves through the assembly, that camera is coming right along with it. You're just using the motion manager to create those paths for that part. So again, kind of a unique way of creating an animation in your assembly utilizing cameras. The first time you do it, you might find yourself fumbling around with it a little bit, but it's pretty neat, especially if you have an assembly similar to the one that I showed on the screen. Okay. Now I do have some time where I can talk a little bit about motion simulation inside of SolidWorks, and then we can also talk a little bit about event-based simulation. The thing with motion simulation is, well, first of all, let me say it again, that this is part of SolidWorks Premium. So not everyone listening in on this presentation is going to have this capability, but it's something that you might be interested in down the road. Motion simulation is for, it does use the motion manager, just like we did when we were creating AVIs or creating an animation. But it gives you more capabilities. When you solve the animation, when it's finished, you'll get much more feedback. Like, for example, maybe you're interested in power consumption on a motor or reaction forces, velocity or acceleration of a component. You can even trace paths of parts and save those off as curves. Contact forces or friction forces when components do come in contact with each other. So these are just a few of the results that you get when running motion simulation. And what I may do here is I can show you just a couple of quick examples. Given the amount of time, I won't be able to get too deep into motion simulation. I think I'd like to find out later if this is a topic that you would like to see more of, and maybe even another webinar, a lunch and learn webinar down the road. Let's pull up SolidWorks and I'll show you a little bit of what it looks like to gather results from a motion simulation. I'll start with this car jack. I've got a couple of examples that I can show, and the benefit here is I already have the mates set up, so I don't have to create any more mates. I even have a screw joint in here, so that's already taken care of for us. I'm going to go ahead again and disable playback of views. We don't need that here. I do need to make sure that I turn on motion simulation. When I turn on motion simulation, you'll see that I get another option for motion analysis inside of the motion manager. And all I'm going to do here is simply add a motor. And we'll just make sure that that motor is going to turn a couple of times per second. Now, right now, if I run this, it's only going to take into account the weight of these components using the gravity that has already been placed inside this. See, there's a gravity button there. But we can also apply a force. So rather than having the car or whatever it is sitting on top of this assembly, we'll just apply a 1,400-pound force. which is probably a little bit too big for this one, but that's okay. Now, when I calculate this, we'll be able to gather some results, like, for example, the amount of torque it's going to take to crank that arm. Okay, so that solves pretty quick. We'll go ahead and select that motor that I just put in. And again, we have the ability to create a plot for forces. We'll take a look at the applied torque, and it will generate a graph that we can take a look at. And these graphs are saved with the file, so if you ever make any changes, you can just go ahead and pull that graph up again to see what the results look like after modifying your assembly. So we're looking at 83 pound-inches as far as torque is concerned. We could multiply that times the length of the arm if we want to know what force it takes to turn the car jack. Okay, this one, it's a simple conveyor system. One of the things that I want to mention here, once it does come up, is that you have the ability to turn mates on and off during this animation. I'll show you this real quick. Okay, notice under my mates, I do have tangent mates for the pallet turned on and off during the animation. So, that's rather than, I guess, using physical dynamics at times to show some sort of, or rather than using paths, you might say, to show the range of motion of an assembly. I'm going to go ahead and play this so you can see it. As that pallet moves down, I have a lift system down here that's going to push this frame up and move the conveyor onto or move the pallet onto the other conveyor. One of the things we talk about a lot inside of motion simulation is the mates that you apply to the assemblies, mate redundancies, things of that nature. That's one of the topics that I suppose we would cover if we had a webinar just on motion. Mates are important because that's where we gather a lot of our information. For example, we might want to know what the reaction force is of this actuator on that connecting pin or that connecting rod. I've got a mate. Let's see if I can find this mate. Okay. Here's that mate, a concentric mate. Again, we can go ahead and find out what is the reaction force. Okay. And once this resolves, then we can take a look at that. So we're looking at 2,500 newtons of reaction force on that mate. Again, these plots will save along with the simulation, so you can always go back to them after you've run it again in case you do modify it in any way. And then we could also check the reaction force of any other mates like this side. What's the reaction force on over here? What is it over there? Those mates, again, are very important when it comes to gathering information at the end of the simulation. Looks like we have at least 10 more minutes where we can cover event-based simulation. Let me just mention real quick, event-based simulation, this is part of Simulation Pro. And I think I might have some examples here that some of you have not seen yet. I'll try to do one from scratch, but I want to start by showing maybe some examples of how this works. Event-based simulation is an alternative method to using the Motion Manager. Rather than using the traditional keyframes and paths and putting those in manually, you could base the function of your assembly on tasks and events and triggers. And so those tasks are going to be triggered by an event. Maybe it's a proximity sensor. It could be a previous task. What happens is these tasks are going to drive automatically the keys and paths inside of the Motion Manager. It's going to make modification much easier if you do have to make changes to your assemblies. Let's take a look at an example. I'll pull up one that has already been completed. Now, I'll be walking through these rather quickly so that I can make sure that I get through what I'd like to accomplish in the next, before the lunch hour is over. If we take a look at the motion study that I have in there now, again, I have the traditional keyframes and paths for motors that I have inside of the assembly. The thing that you want to keep in mind with the paths that you put in for your components, don't forget about applying motors. Motors a lot of times will make the stability of your animation much better. I find myself using these actually quite a bit. In fact, that's another thing that I wanted to mention inside of the gripper earlier, but that's okay. Now I'm going to jump into Event-Based Motion, which is this tab on top of the Motion Manager. And you'll notice again that I have a set of tasks, and there's these actions in those tasks that are triggered by an item, and it might be a previous task, or it could be again a proximity sensor. We'll cover a few examples. Let's disable this here. I'm going to go ahead and play this one. And one of the things you'll notice is it doesn't matter the order of these tasks. They're going to be triggered by one of these items over here, so it doesn't matter where they are in this list. Again, as this is working, it's automatically placing these keyframes in the Motion Manager for you. So if you do want to modify something, for example, a time, then you can change the time over here and have it update the animation for you. Let's take a look at another example. This was a fairly simple one. And this one looks simple, but it's a good example of the functionality of the software. Okay, and here I have a couple of blocks that are going to be pushed around by these, I guess you could say an actuator or something of that nature. And there's proximity sensors that will detect when a component, or when, for example, this piece comes in front of that sensor. And those sensors are made right here in the Feature Manager. You can right-click and add a sensor. You'll notice that I have 3 proximity sensors that have been added to this assembly. Okay. Now let's go ahead and take a look at one of these tabs, motion tabs. One of the things you'll notice is these tasks can be used over and over again. A proximity sensor can be used on more than one component in the design. So when a part, or if you have 2 parts that are affected by that sensor, then this one may be triggered 2 times, 3 times, depending on how many times this sensor will find a part in front of it. Now I'm going to go ahead and play this one so you can see it. And now you'll find that there's no mates for these blocks inside of this assembly. It's only using the contact conditions between those components. But notice that I have an option up here to generate contact sets or groupings between those parts. This one is interesting, at least to walk through too, before I show you a live demonstration of it. Since the event-based simulation is a part of Simulation Professional, then you have all the capabilities, of course, of the motion simulation. So you can take advantage of friction, coefficients of friction, things of that nature, different types of contact conditions between components. So these, I've got this this assembly is going to grab these bolts and lift them over to this little indexer. Now, I also have proximity sensors in here too that will trigger some of these tasks. Well, what you'll notice is there's no mates involved here. Let's drag and drop this down a little bit. I don't have any mates between these components. They're all free to move, but using friction, when this component comes over here to pick this up, once those parts touch, it's the friction that's going to keep them in contact with each other. So I don't have to use mates between them. I'm going to go ahead and play this one so you can see it. In fact, I'm going to play it in regular motion just to speed it up a little bit. Okay, again, when this comes over to pick up that part, friction is going to keep those components together until it lets it go. Now, if you're interested in seeing a little bit of how this works. How do you use event-based simulation? How are those tasks and triggers put in? I can show you a real quick demonstration of that. Let's go ahead and close out of this one. Sorry for the time that we have left here. We were really trying to crunch as much as we could into an hour period. This example, I can show you how we create a function for these two actuators are going to be used to lift this base plate up and place it over on this indexing table. Notice that I don't have any tasks in here yet. I do have a couple of motors and proximity sensors to work with. I'm going to start with just the motors alone. I'll start with task 1, which starts at 0 seconds. You can also put delays in here too. And this is going to change a lift or a motor that I have inside of the assembly. And I basically want that lift to move 112 millimeters. It'll take a couple of seconds, and then we'll go on to task 2, which is to extend the other actuator. And this will happen, it's triggered after that last task. Again, it's we're adding triggers here. We're creating events. I want this other motor to move a certain distance, 765 millimeters. And again, this one will take a couple seconds. We can use cyclodal for the interpolation mode. That just means that the beginning and end of the that path is going to have 0 acceleration. And this next trigger is going to happen after task 2. Again, we're just selecting a motor. We can apply negative values to these as well. If we want this one to go down, we can put negative 112 and specify the amount of time that it takes to do this. Finally, the last one, it's going to retract the other cylinder. It happens after the previous task. This one is happening pretty sequential, but it doesn't have to be the case. Let's go minus 765 for this one, and again, we can just place in a time. Now, when I run this, you'll notice that all it's doing is it's lifting the one actuator, it's extending it over, so the base plate isn't a part of this yet. Okay, it's going to lower it down and return to its original position. Now, if we want to take into account the base plate, we have proximity sensors in here. So let's do that. We want to detach now this base plate from the tray, and that'll happen when we activate a sensor that's already been put into this assembly. It's going to turn off a mate, or it could be a series of mates. It doesn't have to be just one. You can just select as many as you want in there. And then it's going to attach, let's see, it's going to attach the plate to the lift, or to that other actuator. Again, using another mate will make sure that one turns on. Just a couple of more tasks. We want to now detach the base plate from that previous lift when it hits another sensor. We'll make sure that that mate turns off, and then we'll make sure that the base plate gets attached to the table. And this is the last one. Okay, we'll make sure that this mate gets turned on. Because now when we run this, there's a proximity sensor right here, so when that plate touches the tray, oh, looks like I just came across an issue. What did I do here? Let's try that one more time just to make sure. Yeah, I'm not sure exactly, and you might actually see it, and I don't on my screen. But it's going to turn on and off mates that you have inside of this assembly so that we can run through that range of motion and keep the mates in there without having to suppress them. And what that does is it automatically will add, again, the keyframes and the paths that we have inside of the motion study. Okay. So it is 1 o'clock, so what I'd like to do is wrap this up. I do want to thank you for joining us for the presentation on the motion tools. If you do have any questions for me, please feel free to send them at this email address on this page, and I'll do my best to get back to you. And if there's any frequently asked questions, I'll go ahead and add them to the DASI Solutions webpage along with the webinar and the PowerPoint as well if you'd like to have it included on our webpage. Again, thank you for joining us. Thank you for choosing DASI, and have a great day.